What's going on, everyone? You're back with Jono for another quick math lesson. Today we're going to have a look at Pythagoras' theorem. This is really an introduction to a whole topic about right-angled triangles, and this theorem is essential to understanding everything. Right-angled triangles have a really amazing property that always happens no matter what. It can really tell us a lot of information about unknown side lengths if we know a little bit of information before we get started. This video is not going to go into a visualization or a proof of why this happens. There are some really good YouTube videos already up there about this topic, and I've linked them in the description below. All we need to do is look at a very quick example and see how these numbers can relate to one another. So in this triangle here, I've got a right angle, and we can count up pretty easily just looking at the boxes that it is 3 squares up. So we've got 3 squares here. And then if we count across, the base of it is 4 squares long. Now, using Pythagoras' theorem or a connection between these two numbers, I can exactly know how long that long side is going to be, even though I can't just count the squares because it's on a diagonal. What I'm just doing there is rotating the triangle around so we can count up the squares of the long side. As you can see now, it's 5 squares long, and this actually is the foundation of Pythagoras' theorem. We don't want to count squares every single time that we do a triangle. There is a relationship between these numbers that always occurs. So this is Pythagoras' theorem. If we know 2 sides of a triangle, we can always work out what the third side is going to be. There's only 2 skills that we need to know in order to do this. The first skill is we need to be able to see which side is the long side. In that example there, it was pretty easy. And we also have to be able to use our calculator effectively, just because some of the numbers we do get are a little bit hard to work with. But both of these skills are incredibly attainable, and I'm sure you're going to find them all right. So the first skill is finding the hypotenuse. The hypotenuse is just the maths term for long side, right? It sounds a bit fancier, so that's why we use it. The first definition of the hypotenuse is that it is the longest side in a right angle triangle, and that's usually pretty easy to see. But sometimes you'll get a triangle that doesn't look like it has a longer side. Maybe it's a bad printout, or maybe the teacher's just done a really quick example on the board. The other way that you can tell if it is a hypotenuse is that it's always opposite the right angle. So if we have a look at these 3 examples here, it's not immediately obvious which one is longest in each of these examples. But the hypotenuse is always just on the other side of the right angle, which is that little square. So for this one, I know that the hypotenuse is on this side. Over here, the hypotenuse is opposite the right angle, and in this one, it's over here. So even if you can't tell which one's the longest just by looking at it, it's always on that other side. So the formula for Pythagoras' theorem is that a squared plus b squared is equal to c squared. What that means in English is that the sum of the short sides squared, so a squared plus b squared, is equal to the long side squared. And this always happens. And we're going to go back to that first example just to see if it worked out for this one. So for that first triangle, it was 3 up, 4 across, and had a hypotenuse of 5. And according to the formula, that means that 3 squared plus 4 squared has to equal 5 squared. And we just need to see if that's true. If we expand this out, 3 squared is 9, plus 4 squared is 16, is equal to 5 squared, which is 25. 9 plus 16 is 25, so we know that this is true. And because that is true, we know this triangle is a right angle, and it holds up in this case, and we're going to see that it holds up in every single case that you come across. So for this one, we've got 5 and 12 as our 2 short sides, and c as our unknown, and we've got to be able to find what that c value is. So this is telling us that 5 squared plus 12 squared has to equal c squared. You can just chuck that into your calculator straight away. We don't have to expand it every single time. And 5 squared plus 12 squared is 169. So this becomes c squared is equal to 169. What's really important is that you look just to make sure that these numbers make sense. 5 and 12 are both pretty low numbers, and 169 is massive. So that means it probably isn't fitting into our pattern. What you have to remember is we're not trying to find c squared. We're trying to find c by itself. So something that's really important with Pythagoras' theorem is that you always root your answer. In your calculator, all you have to do is hit the square root sign and then hit answer, after you do that initial calculation of 5 squared plus 12 squared, and that gives you the answer of 13, which fits in way better with the other numbers, so we know that we've probably got it correct. Sometimes with Pythagoras' theorem, we don't get a perfect number out of the calculator, which is totally fine. The teacher is going to tell you if they want you to leave it to 2 decimal places or as an exact value. The exact value just means under the square root side, and then you're done. We'll see it in this example here. So my 2 short sides are 7 and 13. So Pythagoras' theorem says that 7 squared plus 13 squared is equal to c squared. I type 7 squared plus 13 squared into my calculator, and that gives me that c squared is equal to 218. Now, if it says exact value in the question, all you have to do is square root both sides and write that c is equal to the square root of 218. That's actually your final answer. Happy days, you're done. But if it does ask you for 2 decimal places, just hit equals, and you'll see that that gives us 14.76 ... and that is our final answer. We know that this is probably right because the hypotenuse has to be the biggest number, and 14.7 is higher than the other ones. So as long as you can remember what Pythagoras' theorem is, the 2 short sides squared and added together, and then root your answer in your calculator, you're going to find Pythagoras' theorem incredibly easy. I hope you found this helpful, and I'll see you later.